Hi, and hope you are doing well. I'm Jadi and welcome back to Geeking Jadi's channel. The other day, we wrote a game using Python. It was fun, I enjoyed it, so I decided to write another game. But writing it in Python would be kind of easy for me. I mean, I know a lot about Python, I'm fluent in Python, so it would be very easy to write. Still, I will enjoy it. It's like writing a game. Playing the game. Some people enjoy playing the game. Some people enjoy creating new games. Some people enjoy programming. I do. So writing a clone for a famous game is a fun activity. And what can be more famous than River Ride, my childhood's game? As you can see, it's an airplane which moves on the river, shoots enemies, gets fuel, and the strange point is, if your airplane moves on the land, you will die. I'm sure this was intended to be a boat, but the designer designed an airplane, so they changed it to the airplane, because normally for airplane should be no difference than going from the river to the land. But this airplane can't. Obviously, we are not going to write this. This is too complicated for a one session, 1 hour or something. 1 hour and a half, I guess. Because I'm going to use something which I'm not fluent in. Rust. I know Rust. It's more than a year that I'm writing in Rust, but I wanted to say you never learn Rust in and out, but you will do eventually. It's a difficult language, and it's cool. And it's not designed for this kind of thing. The reason I'm writing games is because, first, I enjoy it. Second, many of the great programmers you know. Today I was watching a video from Ken Thompson, the person behind Unix and C programming language. He was saying, I didn't wrote or invented Unix or for others. I wanted to play games and I needed an OS, so I wrote Unix. Kind of, not exact words, but the same logic. Many of the good programmers, I just wanted to say, including me, I'm not a good programmer, but anyway, I'm decent. Okay programmer. Many of the okay programmers used to write games. We used to clone famous games. I would see this game, I play it for some hours, and then I would write the exact same thing, clone of this game. Exactly with this fuel indicator, exactly with this logo. The 100% clone would win the prize of, oh, I can do it too. We learned a lot from this. We felt that, okay, I can do the same, although we were using stronger computers. So we were in a better position than the original inventor of this game. Activision, thank you for all the childhood memories. On the other hand, I'm doing this for you because you will see how a programmer programs, how we start making different parts and eventually reach something larger. In the beginning, in this session, if you liked it, I may continue it. I'm going to create this game. There will be a river here. The player will be here. These are the lands. And I should be able to move in the river on different directions. If I hit the land, I will die. And okay, the river will move, so it will scroll. Same logic, at least on the first part. I do like terminals, so our game will be written in a terminal using Rust, which is cool. You will see Rust, you don't learn Rust, I'm not teaching Rust, although I describe parts. Especially if you don't know Rust, I think this is a good opportunity to see how the programming language works. This is a fun part. And you can continue it, you can rewrite in your own language, you can continue in Rust, or whatever. I write it in terminal because it's more fun for me. We can use a game engine, for example, Godot is a very fun game engine, a Python-like language, and lots of other bindings. But when you are in terminal, it can be even a little bit harder because a game engine like Unreal, Godot, whatever you use, will give you the opportunity to have sprites. You can check for the collision of the things. You can do scrolling, you can move your map, place your camera, everything. Now we have to do everything ourselves. And we are doing it very, very, very simple and rudimentary, if I'm correct. So, writing in Rust, we need to create a project. We are in Rust, so I can say cargo new riverride Rust RRR. It will create a project. I will go to it. I will open it in my code editor. It's here. I will maximize this. I will maximize this. Yes, I trust the authors. It's me. And this is our basic Rust program. So let's run it. Cargo run will run a Rust program. Hello world. We wrote the basic part. The rest is only expanding. I will search for TUI in Rust, Terminal User Interface in Rust. There is a very nice and famous project which is becoming obsolete. I used to use this, TUI RS. It's very strong. As you can see, it can create animations. You can resize it. You can have different widgets, make lines and everything. This is super cool. This is being obsolete for the Ratatouille project, which is obviously the next step. But I'm going to use this crossterm. Crossterm is much more simple. Crossterm is a pure Rust, nice, terminal manipulation library that makes it possible to write code cross-platform text-based interfaces. This is much more simple. No widgets, no whistles, no bells. You can go to this pixel, write something here. Then go move the cursor here, write a string here. You can clear the screen or you can read the keyboard with some events. I have used this and it's fun and easy. I'm not an expert, you will see. Okay, so we are going to use this crossterm. This is a sample code. I will use this sample code. We'll replace mine with this. I can also do a git init here. This is our git. Okay, cool. I think cargo new creates a git environment, maybe. Yes, it does because I have the master here. Cool. So cargo run. We will have errors because crossterm is not known. In Rust, I have to add this library. So I will go cargo add crossterm. This will add the crossterm. Now I will run my program, cargo run once more. Cargo is a very nice name for this. Style text. It writes it twice. Because on a sample program, I have the using macros work like this, using functions work like this. I will use the functions. So my program will start like this. It says std out, do an execute on set foreground color, set background color, print this, reset colors. I don't want to work with colors, at least in this session. If you really liked it, tell me. I may continue and we can create a real clone, exact clone of the river ride. That would be fun. Not exact clone because we're in the text environment, but it's fun. Let sc equals this. I create a variable instead of calling like that. So I will have more control and then say sc execute this. Simpler. Okay, what is this? I need this here. Then it's died. It says cannot borrow sc. Okay, sc should be mutable. On Rust, whenever you want to change the value of a variable, it's a variable. If you want to change the value of a variable, you have to define it as mutable. Otherwise, it will be used as a constant. So I say, okay, sc values are changing. I'm running this on it. Once more, cargo run. Okay, style text here. Cool. Now we can write on the screen. We can have a quick look to this thing. Let's find the documentation. Have a quick look to the documentation of the crossterm so we'll have a better understanding. It's a pure Rust, blah, blah. We read these. It has a command API. Okay. It has different modules. Module cursor works with the cursor. We can hide the cursor. This is cool, so it won't blink or be present. We can enable blinking, disable blinking, set cursor style, position, change the position of the cursor. We can move the cursor to somewhere, move to. This is what we are going to do. We move somewhere, draw whatever we need. And then we have the event. Event has keyboard events and mouse events. We will need keyboard events because we need to read from keyboard. Module style, colors and attributes. We are not going to use them at the moment. And module terminal, which has scroll up, scroll down, clear the terminal, set size, enable line wrap. Nice. Command execution. There are two different ways to execute a command. Lazy execution, direct execution. This is very important for us. We need the lazy execution. Because normally, when you want to draw on the screen, this is about the terminals. Or even most of the screens. It's not about the Rust or crossterm. I have to move somewhere and write something. Then move some here, create this. Then move here, create this. Then move here, create this. This will clear flickering, flashing. You won't feel that this is a stable program. There will be just blinkings because jumps here to write something. Jump here, write something. Jump here. This will be shown and this will be ugly. The better way is being lazy. Being lazy. Just tell it, I want this here, I want this here, I want this here, I want this here, but don't draw them, be lazy. I want this here, I want this here, draw. It draws instantly. This is a better method. There might be better methods like having a buffer, a memory place or whatever. But this is good enough for us in this project. So lazy is telling it what to do and then print the output. I saw the command here, flush the output. We queue the commands instead of executing commands. I saw execute here. We were saying, okay, create a screen, execute, print this. We could say sc execute. I saw the move to. On my ID, I can say, okay, enter. So I'm going to use that specific move to. We can try 5 and 20 and say, see where it writes. It says unused result. It returns a result. So I can have this. So I'm moving somewhere. I'm printing somewhere. Let's run this one. It wrote it here. So 5, the first argument is the columns. It goes 5 and goes down 20. So columns and this. Okay, we can do the same with the queue to make sure that it works fine. Say, okay, I need the queue. I need the queue, and then it says I need the sc flush. Flush all the output. What's the error? What? Okay, it says result is not used. I say, okay, use the result. Because normally on Rust, functions do not return, for example, integers like we do in C. They return a result. Result can have a type and an error like this. So when I say this, I say I need the result, whatever type it returns. If it's a problem, do something by yourself or something like this. So cargo run. Same thing happened. It wrote it here, but with a queuing. So we had the queue. This is the direct execution. I don't need it. This is a good sample. This is what we are doing practically. Nice. So now I'm able to draw something on the game. But let's describe what we are going to do. My logic is this. We have a screen created here. Then it has columns comes first, we saw in the documentation, then lines. So I have these lines here, columns here. 0, 0 will be here. And based on this logic, columns and line, I mean max column and max line will be here. Okay. What I want to do is I want to create a river here and a player here. In most of the games, or maybe all the games, you always have a game loop. You have a loop in which I read the input, here the keyboard. If something is changed, I change the status of the player. There should be variables for the player. I can create a variable called word, which defines my word, in which I say players column equals max column divided by 2. So it will be in the middle. Player line equals max line minus 1. So it will be on the last line. This is the max line. So when I push up or W as a gamer, the game will check in the loop in the inputs and will decrease 1 from player L, and player L should go here. But I'm not moving it yet. I'm just changing the value. I'm defining what the game loop is. In the beginning, I read the keyboard. Then I run some physics. On the physics, I can say, okay, if there is a bullet moving, continue, move it once more on the direction it's going. If the player hit the land, player is killed. If a ball is dropping, increase 1 to the line of that ball. So ball will go 1 down. I'm just doing on the variables. I'm not drawing anything. As soon as this is done, I can call a draw. And this will draw the screen. This is a general method in writing games. We create a loop, we read our inputs, we do whatever we need to do, physics or decisions or enemies AI, they decide where to move and everything, and then we draw the screen and the loop continues. This is how games work. Let me write them. So, and obviously we have to have an init in the beginning. I init the screen here. Then I can say init the word, some word initialization here. Then, interestingly, I have the command loop in Rust. It creates loops, surprisingly. And I say read the input, do the physics, draw the word. This loop continues forever at the moment. Later we will decide how to die and everything. It says your code will never reach here. I say no problem. So let's create our word. On Rust, kind of like a C, we have a structs. So I can say I have a struct called word. In this word I have player columns, which is U16. Player lines, which is U16. At the moment this is enough. U16 in Rust means unsigned integer, 16 bits. This is a little bit large to the power of this. Normally our word on a U8 it will work on my screens. But there are 2 reasons why I'm using U16. One is this game may become famous. You may love it. You may tell your friends, subscribe, or people may just continue playing it in 20 years. And our screen is becoming larger and larger. So having U16 guarantees that in 20 years from now, people will able to play it on the latest technologies with a very, very, very large screens. But more seriously, maybe not more seriously, just another point is in Rust, in many places, system is using U16. So when I use U16, it's easier to add, to use, and everything, because Rust is very, very, very serious about not mixing types. If I have U8, wherever I want to add it to another variable, I have to make sure both are the same. And U16 is kind of standard. So here I just created the structure. I need to initialize it here. I will say let mutable word, not the capital word, equals word. Player C is max of the page. So max of C divided to 2. Player L equals max lines minus 1. But I don't have these variables, but I'm sure I can find them. It says, okay, this is not defined. I say, no problem. I will go to my documentation. In terminal, functions, I have these functions on the terminal, and I have the size. Returns the terminal size in columns and rows. Window size returns the struct, which is window size. I need this size. So I can find my size of my terminal here. So just before this or after this initializing screen, I can say let max columns and max L lines equals size. My IDE will ask, you mean crossterm terminal size? I say yes, exactly. This will automatically add this size to this use crossterm and says, okay, from terminal, I need the size. This is cool and makes everything easier. There is an error. Mismatch type, expected enum result. Okay. The size function returns a result. This is a Rust concept. I have to check and say, okay, I need the okay part. I can say unwrap this. What unwrap does, I say, okay, size is returning a result. I say, okay, unwrap whatever it returns. If the size returns an error, it cannot read the size, whatever, my program will panic here and will finish. Otherwise, the results will go to max C and max L. So now this is correct. I can start creating my functions. I can cut this and write the draw function. I can say I have a function which is draw, which should eventually draw my word. What it does, it uses SC, so I have to pass the SC. Here I have to pass the SC. I have to say SC is the type of std_out. I've seen it here. SC is a std_out. I have to add std_out here. Okay. And then I have to draw my word, how my word works. I move to the, this also needs the word because I have to draw the word. Word of type word. So what I have to do, I have to add it here first. So I'm sending word and screen to the draw function. This draw function is responsible to draw the screen. I can say draw the player. Go to the where word player columns and word player line and draw my player, for example. Then flush the screen. Some errors. SC cannot mutate. Whenever you want to change a variable, you have to define it as a mutable variable. So I have to say my SC is mutable. This says you are returning something. I'm not returning anything. So let's return something. I say, okay, do this. And when done, return an OK, which indicates that program is working fine. Okay, let's see. Now I'm drawing my screen, the player, and my loop is here. So this should work, hopefully. Didn't. Help add blah blah. Expected blah blah found. Okay, I defined this. I need a semicolon at the end. Another error. Value moved here. Ow. On Rust, you don't have garbage collector, and there is a very specific way of borrowing and returning back variables. I have a loop. When I call this, practically I give this word variable to my function. And when returning back, I don't have it anymore. Only one entity can control it. So I have to say borrow this. And when calling it, I have to say this is borrowed variable. Now you have it here. And when you are back, you still have it here. And it says you are returning a result but not using it. Okay, this was because of this. When I have this, I say, okay, check the result. Now it should be better. Cool. We have our P here, but we have this ugly cursor too. I broke it. Now I can go and get rid of that ugly cursor. When initiating the word, we had a command, sc, execute. The command was hide. And when finishing, I can say sc, execute, show. Yes, it has show, so let's get it back. Also check the results. Why is this? Okay, it says you'll never reach here because you have an infinite loop here. Very nice language. Rust is more difficult to write, honestly, and more difficult to grasp if you are coming from a Python word, even from a C word. This result and these kind of stuff are, at least for me, complicated, but after some time you will get hand of it. This is another concept. This is returning something and you have to consume it. You cannot just forget about it. And it understands that you will never reach here. Or for example, now it understands that you defined your word as a mutable variable but never changed it. Please don't. Okay. Let's see if hide and show work. Nice, we have player, P here, without the ugly cursor, Control C. Back to our logic. Now I need to read the input. And based on that, move the player. Let's go back to the crossterm and see how we can read the input. Crossterm had different modules, if you remember. One of them were the event module. The event module provides the functionality to read keyboard, mouse, and terminal. Later we can create a shooter with our mouse. Would be fun. Maybe another video. Tell me if you like this. These are long, these are 2 into 1 language, but still much less audience, but better audience. We are not looking for numbers. Okay, it says the event has read and has poll. Make sure to enable raw mode in order for keyboard events to work properly. Ow. Take note of this. This is a blocking read. We don't want blocking read. Blocking read means it waits for the input. We need a non-blocking read. What it does, okay, this is it. What it does, it polls for this much time, half a second. If in this time there is something to be read, it reads it. Otherwise, it passes. So it waits for half a second for your keyboard input. If it reads something, it works on it. It works using it here. Otherwise, it just goes to the next command here. This is what exactly we want. On this read the input, I can use that code. Because normally in your game, you don't want the whole loop to start. Wait for your commands. I used to have a grandfather. He was playing Snake on his phone, the old phones with snake thing. But he was super slow. He used to use level 1, which was very easy, and just play it like this. Just thinking and moving to the next. We don't want to do this. Even on that slow snake, after 5 seconds, Snake was moving to the next stage and he had enough time to think and decide. But again, the loop is working. So we need this to wait a little bit. If the user didn't respond, go to the physics and draw, because enemies will move eventually. What we do here is, this is too much. We will wait for 10 milliseconds. It doesn't have the poll. So I will write the poll and says, okay, do you want me to import it? I say yes. We don't have the duration. It says, do you want me to import STD time duration? I say yes. Now it's working better. I will wait for 10 milliseconds. Then I will read something, import it, event, import it. Okay. But we have to read a little bit more and see how this works. It says this reads something from the keyboard, then matches it against this. And we have to work on this. This is focus gained, focus lost, key event. This should be the one we are looking for. Mouse event, paste event, and resize event. But where are these? Okay, events. Each event can be one of these. It's an enum. C and Rust both uses enums. I need this one only. So here I can say, I don't want these. I don't want these. But when you're creating a match, you have defined for every single possibility. So I have to say, anything else, do nothing. Error is gone. So read something, and instead of this, which is a little bit ugly, not ugly, but more difficult for me, I can say, let key equals read. This is, for me, cleaner. It reads in the form of event. So I have an event here. If I say match the key with something, but I don't want to match the key directly, because key is what? Is an event. So I have to say, let's check the documentation. Okay, the key returns another key event. And that key event do have a code which can be kind of a key code. This can be a little bit confusing, but let's write them. Okay, I'm matching the key. I read the key, I'm matching the key. I have to say, if it's already have it, if it's event key, call it event, which is kind of event key, do this. Now, in this section, I'm reading from keyboard into event. But my event still needs some checking. I can say, what does this say? Mismatch type, expected enum. Okay, here we need an unwrap. Now my event is event from the key type. If this is the case, I have the event. What I should do? I have to match that event's code, I believe. Yes, this comes from here. You see, I get an event in the beginning. I check it against key type. So then I check it with the key event and the code. But the code is in the form of key code. These are the key codes. Backspace, enter, left, right, and I have to check with this. And we have this character here. So I can read it like this. Key code character C represents the C. This is a sample. Also, if you check here, it says mismatch type, mismatch, missing match arm. You are not checking this against print screen. against caps lock, so we are in the correct way place. I say check this against key code character Q. If this is the case, break the loop. It says key code. I don't know about key code. I say, okay, this is this. It says still you are not checking against whatever possible. I say, I know what I'm going to do it now. Whatever else, do nothing. This should do it. Was a little bit complicated, but I hope you understood. We poll for the input. If there was an input, I read it into the key, checked if the key is the event key, because this could be any event. If it's key, I checked its event code. If its event code is character Q, broke the whole loop. Exit. Let's check. Okay, my P is here. Enter, enter, enter. Nothing. Key. Okay, Q worked. When I said Q, it needs enter. Silly. This is the one we opened about raw mode. Because normally terminals work in the mode that you write something and you push enter. But when you are in a raw mode in a terminal, it reports whatever it gets. You need to enable raw mode. So we need this function. I understood this when I pushed enter and it worked. So on the main, when initializing the whole thing, enable raw mode. This is cool. And on the end, most probably we need to disable the raw mode. Cool. And consume the output. Okay. Okay. Q exited. Very interesting. So now we have most of the things. We can write on the screen. We can read from the keyboard. After this, it's only programming. Up to now, we had technological risks. We may not able to read the keyboard. That would be a huge problem. Now we are just programming our game. I say, okay, if it's W, it's up. What I need to do is, if word, this is what I'm doing now. I have my P here. I can read the keyboard. If it's Q, I break the loop and exit the game. If WSAD, I want to go to the up with W. So I will check the player's line. If it's not out of the range, I will reduce 1. So it will go up. And you remember, we are just changing the variables. The draw will take care of drawing this in place. So I say, if word player L, I'm going up. So I'm decreasing it. So it's larger than 1. Right? Word player L, reduce 1. If this works, everything should be like this. I need 3 more for 3 other directions. If it's S, we are going down. So if it's smaller than max lines minus 1, I have to add 1 to the lines. If we are going to the left and our columns is larger than 1, decrease 1, add 1. If we are going to the right, and if we are not out of the range, so if it's smaller than max columns minus 1. This should work. Let's try. Yes, it's working, but we are creating a track. I'm just checking to make sure that the 4 regions working. I'm creating this because I'm not clearing the screen, which whenever I draw, I just draw the player. So it has become like a snake. So in my draw, I need to clear the screen. Let's check for clear. Clear type. A command that clear the terminal screen buffer. Different ways to clear the terminal buffer. Clear type, all. So we need the clear and we have to define the clear type. So on the draw, when it starts, I say sc, q this command, clear from cross terminal, and I have to define a type. Clear all. Okay, I need this type. Consume this, and this is fine. Cargo run. We have our moving player. So what we can do is also add one clear. Let's add this to the end screen. When it's done, clear the screen. Game is finished. Clear the screen. Go to the 0 column and line 3 and write good game. Thanks. Q. Good game. Thanks. Very nice. And we can add a new line. So now we can move. It's very nice. Now we have a player who can move. Now we need our lovely river. How this river should be drawn? One idea is creating a large matrix of numbers for every pixel, 1-to-1, and fill it with the data. But this will be too much memory consuming, not very interesting. Even if you have enough memory, for sure you have, the problem is drawing these one by one is slow. But look at here, where the river starts on the first line, for example on 20, and it finishes on 40. Where river starts and ends on the second lines, 19 and 39. Where river finishes here, for example 25 and 45. So just remember these numbers and you will be able to draw the map for every line. So it's enough to have one array of 20 and 40. On the next, 19 and 39. And on that line, 25 and 45 to the end. And I only need the size of max lines. Very easy to draw. And when we want to draw them, it's very easy. Go to the first line, read the first one or 0, and draw land for 20 pixels. Then go to the second one here and draw land to the max C minus 40. And you will have your river. Let's go for it. First, I have to add it to my structure of the word. I call it map and say it's a vector of U16 and U16. This is just a definition, very general definition. Later, I have to say in my main, when I'm creating and initializing my word, see now I have an error here which says you are not defining map. I say, okay, I will. Vector, it's a macro to define vectors. I can start with max C divided by 2 minus 5 and max C divided by 2 plus 5. So wherever I have this, My river will start at middle -5, middle +5. So this will be my river in the beginning. How many of these do I need? I have to continue for max line, or as in Rust, I can write max line. I don't have max line here. What this says? I was looking for a U size, but you gave me U16. Please give me U size. It's very serious about this stuff. Say okay as U size. And boom, done. Now we have our map. But it won't work because we just only have our map. We need to draw it. So in draw, I say draw the map. I say, okay, I need a loop. For line in. Word map len right for every line, draw that lovely thing I just described. So SCQ, move to 0, start from column 0 on line L, which is increasing. This is cool. SCQ, now print what? The land. Land will be plus for the moment. I can repeat it. Yes, for some numbers. How many numbers? Word map L 0. 0 will tell the first one there. Ouch, lots of M. What is this? U size is not an integer. I know U size is not an integer. What? Ow! Sorry. This was the in. Okay, this is how it should be. I was writing in a wrong way. L is not U size, at U size, as U size. How? Move to L. Because L is U size, so U16. And then this Q has an error, unexpected type. Print, print this, repeat. Clearly it will ask about U size and everything. Word map, you can convert a U16 to U size as U size. This is very important. Looks tedious work, but it's very important for Rust, and that's why when Rust is running, it's safe, memory safe. So now we have the right side as I described. I created a loop on this. Every time I printed 20, this is just an example, I printed 20 plus sign from 0. Now I have to go to 40 and print how many? Max C minus 40. And minus 40 is word map L1. 0 was this because this was how I represented it. So again, SCQ move to where to word map L1, so move to 40 in the beginning on line L. This is it. And then SCQ print what? Print my land, but repeat it how many times? Max columns minus word map line L1. Should do. But we have to see. It says most probably this is not blah blah. Cannot find value max C. Okay, now this is word max C. Huh? I don't have it here. Let's add it here. This will make our life easier. 16 max L U 16, because we will need it in lots of places. And when defining it, I will say my max C is whatever I have as max C. My max L equals max L. Nice. And this should be of type U size. So I will add a parenthesis here as U size. As U16. But since it worked, let's see. But we have a small issue somewhere. Why we don't have all of them? Q. Let's see what the problem is. Word map len. My word map len was max lines. Why I don't have everything here? And the last one is not... Ow! Okay, I think it's drawing too fast. Something is happening. We need to slow it down because it's just trying to write and it cannot be very, very, very concrete. Let's... it's always good in your loop not to do the fastest possible thing you can. Slow it down. Computers are fast enough. Rust, sleep. How can I sleep in Rust? This is how you sleep in Rust. Add this. I need threads, blah blah. And on my loop, each time I draw, I need to sleep a little bit. 10 milliseconds is this. I say thread sleep for 50 or 60 should be good. Let's try once more. No, this is not the problem. When I click, it works. So, where is this problem? Here, here I Right, but I don't flush. This is the main problem. Yes. But there is an issue. I can feel it. First, let's draw the word first and player next. So my player can't go over that. I should die, but at the moment, it's good to show the player over that. And also you can have some parts for drawing enemies, drawing animations, or drawing funky things. You saw here, we have this. These are total nonsense, but you just draw them. So you can have an array for them and draw them. So it's better to draw the main map first, then draw the enemies, then draw the player. So we'll have them over the other ones. And we had this problem. If you can see my keyboard, I'm going here. Again, we have an issue. I don't flush. No, I flush. Draw the player, draw all of these. My clear is here. Very idiotic. That's the problem with copy pasting. So I draw, first clears the screen, draws the map, draws the player, and flushes. Now it should work. Yes. But see now what is happening. It's kind of late. I'm going to the right. Now I'm going to the top. Now to the right. You can see it has some delay because it buffers every input. And this is bad. It happens here. When I'm reading the keyboard, it checks, wait for 10 milliseconds and make if you can read something. There is something because I'm keeping the button down. So there are lots and lots of going right in the keyboard buffer. And say, okay, read one of them and apply. Then go and draw. Then sleep for 60 milliseconds to make it a little bit slower. So there are lots and lots of other events in the keyboard buffer. I have to empty them. One easy way to empty them is this. I say, okay, if there was something in the keyboard, read it. Then, while there is still something in the keyboard, I have to unwrap it because it's a boolean. I need the boolean. So read whatever is in the buffer. When you read that, without waiting, while anything is in the buffer, let dummy variable to equal with read. This way, I'm saying, wait for 10 milliseconds. If there is something in the buffer, read it, then read whatever is in the buffer and clear it. This is a dummy variable not used. So I'm just reading whatever and emptying the buffer. Up, left, right. Now it's working fine. But I need to die. Everyone dies. Okay. Hopefully. I mean, the worst day would be when the rich cannot die. I don't want to kill the rich, but I'm from a... At least we are happy that everyone dies. Okay. Die is false. And I would say die is a boolean. It would be better to define die as a, not even as a die, define it as a status with an enum and define something like showing animation, died, finished, won, playing, and check for those and finish differently based on the status. Or if you were in a position where status isn't showing animation, something is exploding and wait, don't do anything else, and those kind of stuff. But let's have that for now. Here on the loop, I'm continuing to the end of the word. I can say, instead of this, while word not die. When you are alive, continue this. And instead of this break, I can say word, no, break is enough. Here, technically I haven't died. Let's not break it. I can create to-dos here. For example, here I can say to-do, create enum with died, playing, animation, pause, and lots of different things. So I can have a better control. In programming language, you can do this. Your IDE may show this later. So I want to check if I have died. And the good news is it happens in my physics. You remember our loop. Read the keyboard and act if something is needed just by changing variables. Do the physics and then draw the screen. On the physics, you can do different things. For example, if you have a platformer game and your player, you pushed space and the player jumps. You create, for example, if you are doing like mine, on the word, jump will be equal to 5. So every time you reach your physics, you will check. If the jump is not 0, increase 1 to the position of the player. You are jumping and reduce 1 from this. Next time you will go here. Next time you will go here, here, and here, and the jump will become 0. So you are not jumping anymore. So on the next round of the physics, you may check that if jump is 0 and there is nothing beneath your player, reduce 1 from its lines. Your player start to fall up to here. This can be very, very fun. So I need the function physics. What I should get is the word only, because I'm not changing anything on the screen. I'm just changing the physics of the word from type word. So we want to check if we have died. Again, it's kind of easy and fun the way we created our word. For example, your player is here. It's on line L. And we have a map, which is an array. You check the element L, and this is my river. I check element L and have 20 and 40 there. 20 and 40. So if my player's column is less than element 0, or my player column is larger than element 1 on map L, I'm dead. We are a boat. We are not that kind of airplane which can go over land. Although you know that river-rise airplane cannot go over. So, physics. If word player column is smaller than word map, which one? Player L. Word player L. Okay, and or word player C is larger than word map. Which one? The one player is on it. Okay. Here we have to say, okay, element 0, element 1, we are dead. Check if player hits the ground. Bang, bang. If this is the case, word died equals true. I think I used die. Died is more correct. If you want to do this correctly, you have to say, I want to refactor this. I think Control F2. Refactor this with died. It will change the all instances here too. Knowing your ID is very, very good and helpful. I'm not good in VS Code, but trying to understand. I used to use Vim, by the way. Anyway, on our physics, say, okay, if this is it, die is true. And I have to return the variable word. If you want to do this, you have to do it like this. Okay, if it returns correctly, return the word. And here you have to say, I want to return result in the type of what? Word. Says I don't have result. I say, okay, add result. Says, okay, parenthesized, what? Parenthesized type parameters may only be used with functions, blah, blah. I need these. This is another thing about the Rust, which is kind of complicated and you need some time to grasp it. Okay, this cannot be this. I need uname as uname. And this as uname. Use size. Old habits. Then word died is true. Cannot mutate immutable because this is immutable. Now it's mutable. I can change it. Should be okay. Now we have our died. Let's see if it runs. Physics. An argument after word is missing. Physics, I will send it the word. Player 1, value used here after move. Okay, the point is, I'm sending the variable here, I'm returning it, but I'm not giving it the value. So send the word to physics, save the changed one. Expected struct word, okay, because it returns an okay word, I have to unwrap it. Beauties of the Rust. But Rust has a super cool explanation about the errors. Whenever it sees an error, it gives you a very nice explanation of what happened. Let's crash. Okay, obviously. What happened is I crash here, but when if it's larger? No? I think this should be equal. On the physics, I check if my word player C is smaller than this. Smaller than this. Smaller or equal than this. Larger or equal than this. This should be the case. No. This shouldn't be. On the right, it is correct. Just try an error. Okay, this is good. This is good. Now it's nice. We die. The only thing which is remaining is moving the word. This is becoming too long, but okay, this is what we are doing. We are writing a game. I need this word, and I'm writing and explaining what I'm doing. This is make it much slower. I have this P. I need to move this thing. How can I move it? These are lines, right? It's enough to say this one is discarded and replaced by this one. Copy this on this, copy this on this, copy this on this, and copy this on this, create a new one here. Let's do it. This happens in our physics because word is moving. Move the map downward. 4 lines in. What? From 0 up to word map len. And we need to do this in reverse, not to break things, not to overwrite things. So I say whole of this reversed, because if I copy from the top, you are copying something on everything. What should be done? Map I plus 1, sorry, L plus 1 equals map L. This easy? It seems so. And we have to do -1, not to break the last part, and this is word map. This was super easy. When this is done, what should be done? We have to create a new line on top. Let's create a silly dummy one here. Map 0 equals 20 and 40, as we always say. Ow. Ah, this is super cool, but I'm stuck here. I died. But this is cool. It's a little bit fast. Let's make it a little bit slower. Here we can say slowness. Better than that. And here we can say on our main, on the game configurations, say slowness is 100. Too much Python will kill you. Let slowness. Now it's much nicer, but I don't have a way to go. And died. No problem. Okay, so what next? Practically we've done whatever we needed. We only need to change this to something more fun. We need random here. All the games need random. Rost random. When you don't know something, just search it. Rost random. How does it work? There is a sample here. Let's check the modules. I need RNG. How does RNG work? I want to find example. Let's provide methods gen range. So this is how I can get a random number between blah blah and blah blah. Let's go here, import the random, and then on my physics, for sure I will need random everywhere, so I will add it here. Here I need a random place. It would be a little bit tricky to find something good, but let's try. My river is here. I've shifted everything down and I want to create a new line here. We can do something. Read this and -5 + 5 create a random number. Same with this one. And then check if these are very small, expand it a little bit. So I can say, I can jump or I can do something nicer. I can add it here and say next right equals you 16, next left equals you 16. What I'm going to do is having the same logic, have this, and you want to create a new one here. Okay, what I'm going to do is say, okay, create a random number. For example, my next left should be here, my next right should be here, but don't jump because that would be ugly. Go step by step to reach that. This would be nicer. When starting, I can try this and say next left equals max c -2. Sorry. Yes, max c. We were doing -5, but I can tell -7 to make it a little bit larger in the beginning. Next right equals max c divided by 2 plus 7. Did I say minus? Okay. And then on my physics, I say, I move the map and now I need to create the first line. I say if, I'm saying too much, I say a lot. If word next left is larger than word map 0 left, so 0, the first element, what should be done is word map 0, word next left is larger, so I have to add 1 to it, right? I think so. Okay. See, this could be a very large issue in Python or C. No, they would complain. But I have to add to the first element. I need 4 of these. And I say if next left is smaller than this, remove from it. From the element 0. So if it's smaller, I need to reach there, so I will remove from the column. If right is larger than element 1, so here it's larger, so I need to add to element 1. And if it's smaller than element 1, remove from it. Why we have an issue? Okay, for sure. 1. Remove. This looks very nice. what I want to do is I have this, I have my map, I have 20 and 40, but next is, for example, 30 and 45. So add 1 to this, make this 21, add 1 to this, and go slowly toward 30 and 45. Let's see. Okay. Okay. Use of undeclared crate. I don't have this module. Cargo add rand. Cargo run. This is super nice. And I can move and I can die. Cool. This was nice. The only thing which is remaining is making this kind of random. I mean, now we have the next. We have to say if word next left equals word map 0, 0. These are equal. It's not fun. Let's change it. Word next left equals a random number. How was random? This is the random. This is it. From word next left. No. Oh, okay, it's equal, so it's easy. Next left plus what I'm saying, minus 5 word next left plus 5. This method takes 1 argument. Okay, not this one. I'm thinking because this can make issues. We may go out of range. And I might go here and break things. But for now, let's accept it. I say, okay, if these are equal, add some random number from -1 to put some random number from wherever you are, -5 to +5 here. I can create the same thing for right. Word map 1. Okay, change the right as soon as right and blah blah is blah blah. I can have issues here. I can create a to-do here. To-do. Below randoms may 1 go outside of range, 2 too narrow or blocked. Because these are randoms. I can check for too narrow or blocked. I can say if word next right minus word next left is less than 3, word next right shift it for 3. But this can go outside the range. I will have this to do. No field next right. Because this can go outside of the range, but this is fun. Let's run it and see what will go on. Oh. Interesting. But the problem is this is a little bit like this. Wow. ThreadMate panicked. Attempt to subtract with overflow. Right, because these are U, and if it's larger than that one, the result will be signed, and we said this is unsigned and other stuff. We can add another to do here. Check apps because I want to finish it. One thing I want to fix is I'm always going like this. This is not fun. The fun is having this also as a random. I can say if these are equal and RNG gen range 0 to 10 is larger than 7. So only do this sometimes. You get it? We say, okay, if they were equal and you are going straight, just move it. We say, okay, only on 30% of the cases do that. Although this should be like this, 4 have 30%. We can create another variable and says curviness of the river and configure this globally. So when you reach someplace, you spend that much fuel, you reach this much score or whatever, just make it curvier and reduce this to be bad. And now it's nicer, you can see. Now it's more fun. I think we are done for today. We need some checks for not breaking things and it's getting dangerous. But I liked it enough. Hope you liked it. Comment if you watched up to here. Your comments will be very, very, very appreciated. Tell your friends and we are out of the boundaries. We have to check for this and it looks like it's going that way all the time. Not sure if this is the case or not. Anyway, hope you liked it. We tried Rust. You saw some Rust. You reached here. Tell me if you liked it because I'm in doubt to record these kind of streams because it's too long. I still enjoy it. Anyway, hope you liked it. I was Jadi and this is Geeking Jadi channel.